Okay, so this is for MA 110 final exam review, and question number 6. We're asked to solve for x where we have 1 over 16, and that's all being raised to 5x, and that quantity is being multiplied by 1 over 256, and that's equal to 1/8 all raised to the negative 4x plus 2. So there are a few ways we can solve this problem, but the easiest way to solve it is to think about the fact that 16 is the same thing as 2 raised to something. So 2 raised to the 4th is 16. And 256 is the same thing as 2 raised to the 8th. And 8 is the same thing as 2 raised to the 3rd. So now what I'm going to do is rewrite this equation having base of 2 for everything. So when I do that, I have 1 over 16, but 16 is the same as 2 to the 4th. That's raised to the 5x times 1 over 256. But 256 is the same as 2 to the 8th, equal to 1 over 8. But 8 is the same as 2/3, and that's all being raised to minus 4x plus 2. So now the reason I've done that is I have a common base of 2 on each of these. And so because of that, I can say that this is 1 over 2, the whole thing raised to the 4th times 5, 6. So why can I do that? Well, remember that this has a 4 in the exponent. And so if I had 1 over 2 to the 4th, that's the same as 1 to the 4th over 2 to the 4th, and that's the same as 1/2 all raised to the 4th. So now that I've done that, that's being multiplied by 1 over 2, the whole thing raised to the 8th, using that same idea that I just mentioned. And then that's equal to 1 over 2 raised to the 3rd, but that needs to be multiplied by minus 4x plus 2. That's using the exponent rules. So now I have a half for each of my bases. I have a half for each of my bases. So what that means then is I have, well, when I have two bases multiplied together, so remember, if I have the base a to the b times a to the c, that's the same as a raised to the b plus c. And so in this case, I have this base. This would be like an A, and this would be like an A, and this is like an A. So what I'm going to do then is say that this is 1/2 raised to the 4 times 5 makes 20x plus 8. And that's equal to 1/2 raised to the, and then I'm going to distribute this 3 to everything. And when I do that, I get minus 12x plus 2 times 3 makes 6. So now that I have a common base on both sides, that means that their exponents have to be the same. So 20x plus 8 has to equal minus 12x plus 6. And now that's something that's quite easy to solve. I'm going to add 12x to both sides. So I have 20 plus 12 is 32x's plus 8 is equal to 6. And then I'm going to minus 8 from each side. And I get 32x's is equal to 6 minus 8 is negative 2. And so I get x is equal to negative 2 divided by 32. If I divided both sides. And that's equal to minus 1 over 16. So that's my answer. X is equal to negative 1 over 16. So then what I'm going to do is double check this in my calculator. And I need to make sure that my answer works. So I look way up here at my beginning problem that I started with. And everywhere I see x, I'm going to put minus 1 over 16. And I'm going to do that on my calculator. So I put minus 1 over 16, store for x in my calculator. And I'm going to try this. So 1 over 16 raised to the 5 times x times 1 over 256. And that tells me that the left-hand side is equal to 0.00929. And then I'm going to do the same thing for the right-hand side over here and see if I get the same. So 1 over 8 raised to the minus 4 times x. And remember, I stored x as being negative 1 over 16 in my calculator, plus 2. And sure enough, I get exactly the same decimal, 0.00929, on the right-hand side. So I double-checked my answer, and sure enough, x is equal to negative 1 over 16 works out just fine.